And so thanks to Mark and Celine, we've seen the sublime, and now it's time for the ridiculous. So I'm going to talk today about the intersection of probability and music, so I'll give you a little bit of background. So this upcoming semester is going to be my 6th time teaching an intro probability course. I taught it in the spring here at Duke, and then I taught it 4 times when I was a graduate student. And when I say intro probability, I'm talking about material that you would find in books like this. So it's not my first rodeo, and at this point, I must confess that I'm a tad weary of our standby examples of, flipping coins and playing cards and dice. These are wonderful examples for making specific points, but they don't get the students excited about the material. So in recent years, I've gotten pretty aggressive about trying to bring in as eclectic a mix of examples and applications as possible. Here's a list of some of the things that I've experimented with. And you can see there's a lot of the natural sciences, the social sciences, technology, industry, and so forth. But about a year ago, I noticed that the arts were conspicuously absent from this list. And I was curious if there's anything I could do about that. Now, I myself am a music lover. I'm not a musician. I know absolutely nothing. I possess no talents that I'm aware of. But I was vaguely aware of the fact that in the 20th century, composers started to experiment with something called stochastic music, okay? Which could mean a couple different things. What I mean by it is music where the composer has simulated some random process and then used that to determine what notes they're going to write on the page. Okay, so for example, you could imagine on the right here, I have some 12-sided die. Each face has one of the notes in the chromatic scale, A, B flat, B, up to A flat. You can imagine them sitting at their desk with a blank sheet of paper, rolling the die, and writing down whatever comes up. Stochastic music, okay? So probably the most sophisticated practitioner of this was a composer named Iannis Xenakis. Now, this was a guy who studied traditional Western music, but in addition, for reasons I can't fathom, also studied computer science and optimal control theory and stochastic processes and statistical mechanics, and decided that he was going to incorporate ideas from those fields into his music making. So here's an example of a piece that he wrote. It's for a string orchestra, so violins, violas, cello, double bass, 46 musicians, none of whom are playing the same thing. They all have their own unique, distinct parts. And what he was imagining is that each of the 46 musicians is like a gas particle that is randomly drifting up and down the staff according to Brownian motion. That was the idea, okay? Now, how do you write that down? Apparently, it looks like this, right? This was the manuscript for this work. As the conductor Leonard Bernstein said, when an orchestra performs this music, everybody's on the honor system, right? Okay, so I will play you a mercifully short excerpt of what this sounds like here. Now, do I adore how this sounds? Not exactly. But as a PhD statistician who teaches probability, I can cultivate a certain curiosity and appreciation for how it was put together. Okay, so this motivated me to have the following thought, which was, could I write an assignment for my intro probability students where they take what they know about random variables and probability distributions and computer simulation, and they write their own pieces of stochastic music? Could we do this? And obviously, the second question that I had was, well, it depends. Does R have support for music? Boy, does it. So there's a package, which I am merely a consumer of, called the GM package. GM is meant in 2 senses, so it stands for the grammar of music, because as you're going to see, it provides a ggplot2 style interface for representing music in R. GM also stands for generate music, because once you've represented music in R, it's going to allow you to It's integrated with something called MuseScore, which I was not familiar with, but apparently musicians are. It allows you to generate sheet music and MIDI playback of the music that you've put on. OK, so let me give you a quick demonstration on how this works. So here's a piece of music. It's a short piece. The first 6 bars of a piece for solo piano by Maurice Ravel, who's a composer. So I'll play that. So let's take this and let's transcribe it. Let's put it in R. All right? So the starting point is always the same. You load the package GM, and then the first line is always a call to the music function. And then all of the other elements of the piece are going to be added in layers on top of that. It's perfectly analogous to when you load ggplot. The first thing you call is the ggplot function, and then everything gets added in layers to that. As you will see, it's going to look very similar. So let's start adding layers. So the first layers that we'll add, there's a meter here and there's a tempo. So the time signature, it's in 3/4 time. There's a metronome marking, quarter note equals 60 beats per minute. It's a slow piece. So if you want to add those features to your piece of music, bada bing, okay? Just add in layers separated by plus signs, just like in ggplot. Okay? So now, let's add some more musical layers. Let's add the musical line. So there's two. It's a piano piece. So there's what the right hand is playing, and there's what the left hand is playing. So let's add the top musical line, the right hand part. And how do you do that? You pass in a vector or list with the names of the pitches in the musical line. Now, what do I mean by the names of the pitches? Quick aside. So here we have all 88 notes on the piano, from the lowest A to the top C. Each one has a name, right, in two parts, a letter and a number. The letter is it A, B flat, whatever. And then the number is which octave on the piano does it fall in. Thereby, every one of these 88 notes has a name. Okay. So if you want to add a musical line, there's a line function, and it takes an argument pitches. And the pitches argument is going to be a vector or a list of vectors, character vector, with the names of the pitches in the line. Okay? So you create that, and then you just add it to the layers ggplot style, just like if it was, geom bar or whatever. And then you call the show command, and it gives you, off the shelf, I did nothing. It plays nice with Quarto off immediately. A sheet music preview, and it gives you MIDI playback. So let's play this. Of the notes, right? I didn't tell it any different, so it's treated everything in the line as a quarter note. But if I want to mix that up, that's just an extra argument to that line function. Okay, so in addition to giving it the pitches, I give it a numeric vector of durations that's the same length as the pitch vector. And then now we have something that's a little closer. Okay, right? Different durations, quarter notes, eighth notes, and so forth. All right, so let's keep going. So remember, there's two musical lines. So the right hand is playing in the left hand, so let's get the left hand in there. Again, that's just another layer, ggplot style. So again, here's my line. Takes two arguments. It might take more, but the main one's the pitches and the durations. And note also that if your line has rests in it, those correspond to missing values, NAs. Okay, so it's pretty good. And I just add that layering in there. So let me hit. So here's what we got so far. Two musical lines going. So now let's keep going a little bit. There's other musical elements here. There's the dynamics. I'm only going to do the first 5 bars. So it's a piano. It's a quiet piece. If I kept going, there's other dynamic indications, which you can add. Okay, that's just more layers. Furthermore, there's a lot of expressive indications. There's slurs that connect the notes. It's a piano piece, so there are indications about how the pedals of the piano should be used. You can get all that in there. Okay, those are just more layers, ggplot style. And then we get something that's not a poor facsimile of when an actual human being does it. Pardon me, can we turn up the volume a little, just a hair? Okay, very good. So what we've done is we've represented a piece of music in R. We've represented its meter, its tempo, multiple musical lines, dynamic indications, expressive indications. There's much more that you can do. You could change the instrumentation if you want. For the sake of time, I won't do that. But the bottom line is in R, there exists this package called GM, the Grammar of Music, Generate Music, which allows you to represent pieces of music in R, ggplot2 style, and get automatic sheet music and MIDI playback. All right, so clearly the computational infrastructure exists for this wacky idea that I had. All right, so now can we execute on that? So let's write some crazy music. So I'll give you some examples of stochastic music. So like I said, the simplest piece of stochastic music is the composer with the 12-sided die just rolling it and writing down whatever happens. All right, so let's do that on steroids, essentially. So here's a vector, an R character vector, with the names of every pitch on the piano, from the lowest A to the top C, okay? What's the simplest piece of stochastic music you can imagine? Anyone want to go? Yeah, just sample with replacement from this vector. Okay, so here we go. That's what I'm going to do. So I'm going to just do 2 musical lines, sampling with replacement from the character vector with all of the 88 pitches of the piano. And then we get, here's what it sounds like. Now, I must confess, I'm surprised by how little I hate it. It's got kind of a kick to it. All right. So there you go, right? And now this is, if this was the thing that you were interested in, you could play with different sampling schemes. You could sample without replacement. You can do all kinds of things. But as you see, this is the simplest form of stochastic music without it being vacuous. All right, so let's keep going. Let's keep experimenting a little bit. So, if you ask me what is a melody, to a hammer, everything looks like a nail. So to me, a melody is just a time series. Right, so when we look at the thing on the left here, as far as I'm concerned, that's just an alternative way of writing the thing on the right, which is, you have time on the horizontal axis, the frequency, the pitch on the vertical, I don't know. And so you can follow that thought. We could play a game. So I'm gonna fix a key. I'm going to fix a stable accompaniment. It's going to be like a goofy waltz. And I'm going to stay in the key. So everything will be consonant, right? It's not going to, we're not going to have any more music that sounds like the soundtrack to The Shining. But I'm going to treat the melody as a Markov chain and sort of play around with that. OK? And so what do I mean by Markov chain? Like a first-order Markov chain, where we're doing like a random walk on the C minor scale, for example. And if you change the dynamics, the probability behavior of that random, how does that work? So here's, for example, here's a first-order sort of Markov transition matrix. This is data, actually. Somebody went through 11 songs by the composer Stephen Foster and just tallied up, OK, when he's on a B, how often is the next note a D? When he's on a G, how often is the next note an E? And there you go. That's a first-order. I could put this in the computer and simulate like fake Stephen Foster from this. I haven't done it, but I should. So again, we could sort of simulate melodies from a first-order Markov chain. And if I change the probabilities, I'll change the character of the music, right? And so there's a lot of things you can play with, right? Like if I had uniform probabilities, that's back to like sampling with replacement. But I could adjust the probabilities, right? I could upweight leaps into chord tones, right? The notes of the C minor triad. I could upweight, leaps between chord tones. That's like arpeggios. I could upweight leaps into the tonics, so that's like resolution. So if you change the probability rules governing the system, you change the character of the music in some way. So let me show you. So again, this is like that sampling from a place. This is a goofy waltz thing. So again, right? It's a stable. I wouldn't go to a concert of this, but you get the point. It's a stable. It's a stable accompaniment. That's not the only thing randomized is the melody. Okay. So again, here's what random walk would sound like, right? And when I say random walk, it's okay. Wherever we are, I flip a coin. If it's heads, I go up to the next scale. If it's tails, I go down, right? So random walk in C minor. Okay, right? So you change the probability rules, you change the character of the music, for better or worse. And then the last example here. So this is, I've adjusted the Markov transition probabilities to upweight transitions between chord tones, right? So that's like, again, I'm not a musician. C and E flat and something else. All right. So here's what that sounds. So different Markov transition kernel. Okay. So again, just trying to get a sense of what you can do with this. Now here's another thing that you can do. So this is, I get all due credit. So this is Gwen Jacobson, one of our excellent PhD students. She was my TA in the spring. And when I set all this stuff up, I gave it to her. I said, can you just, take an hour and two with it, see what you can come up with. She, and her idea was, okay, I'm going to input an existing piece of music into R, like transcribe it exactly, and then I'm going to add noise. Basically, so I'm going to randomly perturb the notes up or down according to some rule. And obviously, you change the rule, you change the character of the music. So let's see what she came up with. See how long it takes you to recognize it. All right, you get the idea. So this was again, two non-musicians playing around with this for an elapsed day or two. These are some of the things that we came up with. And so we give this to the students. And so now what was the assignment to them? What was their mission if they choose to accept it? Because this is obviously very low stakes and highly experimental, and nobody's grade hinged on this nonsense. It was write your own piece of stochastic music based on the things you know. And the guiding principle here is explore, again, that mapping from what are the probability rules governing the system, and then how do they impact how the music sounds, right? Explore that mapping. And then the key words here were just to play and surprise yourself, right? And it should be easy to surprise yourself because that mapping is incredibly complex and non-obvious and non-linear. I have no human intuitions about how it's going to be. You have no clue what's going to happen until you try it, right? So that's all I wanted them to do. So I'll close with just giving you a few examples of what the students came up with. This was a student that, right, so all the examples I gave had to do with sort of randomizing the pitch, basically, but there's other things you can randomize. So this is a student that experimented with randomizing the duration, and then they also played with the harmony a little bit more seriously than I ever did. All right, so let's play this. There was that. Let me see. I just liked how this looked. It doesn't actually sound like anything. OK, let's go. I will skip this for a time here. Yeah, they called this. All right, play this. We're back to The Shining now. Yeah, this person was just making fun of me. All right, enough of that. And then this one was very interesting. So this student didn't quite randomize, but they still were well within the spirit of the assignment. Okay, there wasn't anything actually random going on here, but I'll play it and then you can try to guess what it is. This is the sound of something, apparently. It goes on like that. Anybody want to guess what this is the sound of? There are 3 musical lines. Yeah, hit it. No, but that's a good thought. It's the sound of a confidence interval, apparently, right? Because it's 3 musical lines, top, middle, bottom. The middle one is deterministic, just going up and down. And then the way that they decided the interval from the middle to the top and the middle to the bottom, in their estimation, was it's plus or minus 2 standard errors. I don't know where they got the standard error from. Okay, so there was, strictly speaking, nothing random about it, but I like the thought. Okay, well within the spirit. All right, so with that, I think I'm well over time, so I'll close now. Thank you, everybody, for your indulgence. So I just did this in the spring for the first time. I had to submit the abstract for this talk before I'd done anything, and I left a big fat comment like I have no clue what's going to happen with this. So there's plenty of dimensions along which I could try to improve this. It's kind of a fun hobby at this point. And so I'll just, my parting thoughts to you are, obviously, so this was for my intro probability course. You know, to me, that's a mixed audience, folks with all kinds of different backgrounds and interests. They may be stats majors, but to what end? So I aim for maximum variety in the examples and the applications that I use. And, you know, to that end, I'm not afraid to fall down ridiculous rabbit holes, apparently. One thing I would say to you as an instructor, if you have artistic or creative interests, I highly encourage you to pull it in. You will have a tremendous amount of fun developing those materials. And it rubs off on the students when you're highly enthusiastic about it. And then one of the things that I liked about, you know, because our course is basically a math course, you know, as I said, right, the mandate was use what you know to play. It wasn't use what you know to flawlessly execute this calculation. It wasn't use what you know to write an airtight proof, two of which things I care deeply about. That's what our course is for. It was use what you know to play, which is a refreshing change of pace. And then also, you should play with the GM package because it's excellent. The barriers to entry are low. If a schmuck like me could use it, you know, anybody can. All right, so with that, thank you for your time.